Okay, so 4.6 day 2, we are working with fractional exponents again. Explain why we should apply the denominator to this problem first, and would it work to apply the numerator first. So let's talk about this. What they mean by explaining or applying the denominator of this problem would be when we rewrite this, we get the cube root of 8 to the power of 4. And I know if you watch my last video, you know I stress this over and over and over again. It's easier to take 2 to the power of 4 than it is to find the cube roots of, well, let's see, what is 8 to the power of 4? 8 times 8 is 64. 64 times 8 is 512, times 8 again, because it's to the power of 4, is 4,096. So the cube root of 4,096 is a lot more difficult to find than taking 2 to the power of 4 and getting 16. The cube root of 4,096 does equal 16. You get the same answer both ways, but this one I don't know off the top of my head, and this one I do. So that's why it's easier. Okay, so we are going to simplify the expressions and add if possible. So let's go ahead and start by applying our fractions to the numbers. So this would become the square roots of 49 to the power of 1 plus the cube root of 27 to the power of 1. Square root of 49 is 7. Cube root of 27 is 3. 7 plus 3 is 10. So I simplify all the way down, and if I can add them together in the end, I will. So we're going to take the cube root of 1,000 minus the sixth root of 64. So the cube root of 1,000 would be 10. And the sixth root of 64, I believe, is 2. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So yes, it's going to be 2. 10 minus 2 is 8. So simplify first, add or subtract at the end. Cube root of 64 minus square root of 16. And since they're to the power of 1, right, we don't really need to show that anymore, because anything to the power of 1 is itself. So the cube root of 64, this one is 4. And the square root of 16 is also 4. 4 minus 4, we get 0. Okay. The fourth root of 81 plus the cube root of 125 squared. Okay, so this one has a few more steps. First of all, let's find the cube root of 81. I believe 3 times 3 is 9, times 3 is 27, times 3 is 81. So that works. Okay, so we know the cube root of 125 is going to be 5. So now I have 5 squared. So I have to apply that exponent to get 25. Now I can add 3 plus 25 and get 28. So simplify, simplify, simplify. When you can no longer simplify, then you can add or subtract. Okay, we have one more special kind of problem here. It says that the relationship between the radius, r, of a sphere and its volume, v, is r is equal to 3v over 4 pi to the power of 1/3. What is the radius of a sphere that has a volume of 12 pi? Okay, this seems like a very complex problem, but really all we're going to do is we're going to replace the volume, the letter v, with 12 pi, and we're going to simplify the most that we absolutely can. So we're going to rewrite the radius. The radius is equal to 3v, but instead of v, now I'm using 12 pi over 4 pi, all to the power of 1/3. And we're going to simplify this the most that we can. Well, I know that any number divided by itself is going to equal 1. So that means that pi over pi is going to equal 1. I know that 12 over 4 equals 3. So now what I'm really doing is 3 times 3, which is 9, to the power of 1/3. And I'm going to simplify and write it as I can, which is the cube root of 9, which is not a perfect cube, so I'm not actually going to simplify that and find that decimal. I could leave it as the cube root of 9. If I could simplify it, I would. So it seems like a lot, but really all you have to do is replace your volume and then just simplify the fraction like you know how to do. That is it for fractional exponents. Make sure to reach out to your teacher if you have any questions.